So what was yesterday's stuff? Sine law. So if you got this, little bit of review, okay, that's 6, that's 35 degrees. Would you use sine law? Okay, you would probably go, well, this is the hypotenuse for this angle, that's opposite, that's the adjacent, and sine of 35 is opposite over hypotenuse. Okay, if I'm trying to solve for the hypotenuse here, let's assume we are, okay, that's what we would have. Okay, so you would not need sine law here, you would use SOHCAHTOA. It's a right angle. What happens if we did sine law? Well, I know there's this opposite stuff going on. I know this side over the sine of that angle is also equal to this side over the sine of this angle. Okay? And again, if it helps, like do this. Okay? Sine law, it's also equal to, there's a third ratio, right? The sine of that angle, I don't know what it is, I could find it. So I know there's 180 degrees in a triangle over that side, okay? But that's what I have. Does that look similar? What's the sine of 90? When this triangle, remember, if this thing goes right up until it's vertical, what can I say about opposite over hypotenuse? Yeah, it's the same length. And if you don't believe me, put it in your calculator. What's the sine of 90? It's 1. And if I rearrange this a bit, right? Let's just rearrange this one. How do I solve that for h? I switch these and this. H is 6 over sine 35. Do I get the same thing? Yeah, it'll work. I mean, sine law will work, okay? But why would you if you have a right angle triangle, right? You can just use SOHCAHTOA, okay? So that's sine law. This is cosine law. Again, let's look at this triangle. And you guys don't know cosine law. Don't look here. You do know sine law, I hope. What can I do with sine law? Here's a triangle. I know that this opposite stuff, okay, I know that 6 over sine of angle B, it's the same ratio as this side over that angle. What's this side? That's little a, opposite A. And that's the same ratio as this side over that angle. 3 over sine big C. Okay, that's sine law. That's my 3 possible ratios. Okay, what happens, consider this triangle, there it is, they drew it for us. What happens if we use sine law? Can I solve anything here? Well, just look at the first two. There's an equation. Can I solve an equation with 2 variables? No, I can't. Okay? Well, let's look at this equation. Can I solve that? I have 3 variables. Oh, okay, thanks. Yeah, that's 36, all right. Yeah, you're right, I knew that. But I still have 2 variables, don't I? Doesn't help me. All right, well, but because this is equal to this, and this is equal to this, then I can say that is equal to this. Can I solve that? Sine law doesn't help me. I'm stuck. I can't get anything in this triangle. Don't know anything else. Okay? That's where cosine law comes in. Cosine law will help us solve triangles where it's not a right angle triangle, so I can't use SOHCAHTOA. Sine law doesn't help me. got two variables in every ratio, okay? This is cosine law. Okay, so I'm going to skip that one. Let's go over to the law itself. There it is. Okay. If angle A here were 90 degrees, what's the cosine of 90? Yeah, and remember this, if I go up and I make this 90 degrees and this thing gets steeper, steeper, steeper until I have that angle, what's the side of my adjacent here? How big is my adjacent? It's gone. There's nothing. Cosine is adjacent over hypotenuse. If the adjacent is 0, I don't care what h is. Cosine of 90 is 0 times 2 times b times c. That's gone. Have you seen this before? Kind of look like Pythagoras? If you have a 90-degree angle, would you use cosine law? No, because you know a relationship between the sides in a right angle triangle. C squared is a squared plus b squared, right? So we're not going to give you ones like that to use cosine law. I'm not going to prove it per se, but if you want to look there, be my guest. Let's just jump in and use this formula and solve some stuff. All right? So the first part is we're going to solve for, this is the same as sine law. The little letters are side lengths. Okay? Side length, side length, side length. There's your three sides of your triangle. That's an angle. The one thing you have to watch out for, this is opposite this angle. This side is opposite that angle. Just like Pythagoras, doesn't matter which leg is which. I could call that B, I could call that A, okay? These are interchangeable. But the one thing you have to watch, this has to be the angle opposite that side. So this is in the form of solving it for one of the sides, okay? So tomorrow, the second part of this lesson, we're going to rearrange the formula and solve it for an angle. Okay, so that's cosine law. Go down there. What's cosine law? A squared is b squared plus c squared minus 2 bc cosine A. Let's just write it there so we don't have to keep flipping up. Okay, so here's our triangle. That's 36. This is 3. They call it AB, but okay, whatever. Determine the length of BC. And that's the only thing we can get here with this cosine law. This length, can I call that something else? If that's angle A, what do I want to call BC? Little a. And luck has it, that's how my formula is written. Okay? I can use this to solve for A. That's little a. All you got to do is plug in everything else. A squared is, what's B, what's C? It doesn't matter. Okay? Let's call that B just to be consistent. That's 6 squared plus 3 squared minus 2 times 6 times 3 times the cosine, and again, that has to be the angle opposite the side you're determining. Okay, and I have it. That's 36 degrees. Okay? Should be one little transaction on your calculator. Okay, 6 squared, yeah, I know it's 36. 3 squared, yeah, I know that's 9. Minus 2, you can use brackets or times, doesn't matter. I'm just making it look exactly the same as it does here. Is that the length of the side? Ah, psychology. Why is he asking the question, Dannon? Because it ain't. What did I solve for here? That was a squared, not a. So what do I got to do? Yes, take the square root of that. 15.87, and you just want to take the square root, right? You don't want to round this thing off like I'm trying to tell my grade 10s. They'll go, oh yeah, 16, then take the square root of that. Hey, it's 4. No, it's not. Square root of the answer. Now I know that's as exact as I could possibly get it. Is, that's not 4, depending on how they want the question, nearest tenth. So as the nearest tenth, that's not tenths. That is, there is a difference. Well, you guys, are you in chem?
Yeah.
Is that a significant figure?
Yes, sir.
Yes, it is. Oh, it depends on my mood, Dannon. Okay. But if that's hundredths, of course, it's 3.98, right? Does everyone get that? That's a tricky one, right? Rounding it to the tenths, but the 8 makes the 9 bump up. Well, the 9, the only way it can bump up is you turn it to a 0. If that's a 0, you got to make that a 4. That's rounded to the tenths. Okay? That's cosine law. So, looking ahead, if this triangle said, solve me, what does that mean? You got to find everything. This, that, and that. Okay? You have to get a couple of things in this triangle. So the maximum things we could solve here is 3. From this point, now that we have this, it's your choice. Do you want to use sine law to solve for the other things? Or do you want to use cosine law again? Okay? Your choice. Once you have one of the other angles, though, do you want to use sine law or cosine law to get this one? Why bother? 3 angles add up to 180. That's the easier way. Okay? So there's lots of choices in how you're going to solve this triangle. Okay, let's get another cosine law first. Find the length to the nearest tenth of a centimeter of the third side. What? Yep. Yep. Determine the length of BC. Let's call it A. All right? Okay. Any A, B's, and C's in this question? Doesn't matter what letters you use, okay? I know the form of the cosine law in the book's got A, B's, and C's. It shouldn't matter. That first letter squared, little case, has to be opposite the angle. Okay? That's all you got to remember. Let's fill some stuff in. QP is 1.7. That's over there. QR is 3.1. That's there. Make it nicer. And PQR is 110. Okay? Look at the middle letter or trace that thing with your pen, pencil, your eyes, whatever works. But is that the only angle that looks like 110? That's the only obtuse angle. That has to be it. Okay? I didn't even need to look here, really. Okay? What could I find? Well, the third side. I only got one option here. Is this going to work? Do I have the angle? Let's call it x. Do I have the angle opposite x? Yeah, because if you don't, you can't use cosine law. I do, right? So let's call it x squared, or actually, you know what? Let's not get all confusing. There's q, let's call it little q, okay? Q squared is little r squared plus little p squared minus 2. Let's start drilling this in our head now, not blindly copy out notes. What letter do I want here? Sure. R. Then what? P. Good. Okay. Times cosine of what? Yeah, but I'm not putting any substitutions in here yet. Big Q. Okay? Would it be wrong if I had PR here? Public relations? No, it doesn't matter, right? You multiply in any order. Okay? That's cosine law. Do you have that in your formula sheet? Is that in your formula sheet, first page? Look at that. Don't even have to memorize it, right? So, I don't know if this is helpful, but maybe for some who forget to take the square root of it when you're done, maybe you want to do that first. If that's q squared, q is the square root of, what's r? 1.7 squared plus 3.1 squared minus 2 times both those numbers times cosine of 110. Okay? Can you put that in your calculator? Sure. Square root, come on. Square root of 1.7 squared plus 3.1 squared minus 2 times 1.7 times 3.1 times cosine 110 bracket. Now I got to bracket the whole thing, or it's not going to be right? Everything has to be under the radical sign, not just the first thing. If I didn't put that bracket there, all it's going to take the square root of is the 1.7 squared. Right? So I got a bracket for the 110, and I got a bracket for that. If that's confusing, just do it the way I did it the first time, right? Does the answer look reasonable? Look at your triangle. Does it look reasonable? Yeah. You can't call it a hypotenuse because there's no right angle, but that definitely is the longest side. To the nearest tenth, that's 4.0 again. Okay? Any questions so far? Just got one more. All two of you guys who have been in my physics class are going to have an advantage with this question because we're talking about directions. If you know and like your soggy wiener thing, Dannon, then you can use it. Bellevue is 30 kilometers, or was that Lewis? 30 kilometers north of Ayr. Let's just, you see how that's a B? I don't want to write Bellevue on my picture. Ayr, let's call that A. And Churchville is 18 kilometers northwest. We got to know what that means as a direction. Any ideas? Do we see an angle in our head in degrees? Okay, so let's solve that first. That's north is up, south is down. This is what I'm talking about with the soggy wiener thing. Which way's east and which way's west? How do we figure that out? Now, some people have learned to never eat soggy wiener. But do you go clockwise or counterclockwise?
Clockwise.
Never eat soggy wieners. See, I don't, if that works, great, use it. But to me, I'm like, okay, I remember that part, but do you go clockwise or counterclockwise? What helps you remember which way you go? Because if you go the other way, never eat soggy wieners, now you got it backwards, okay? Here's an easier way to remember this. Because some of us, there's a lot of really intelligent people in the world who are dyslexic, okay? P's and Q's, they can't even read them. They screw them up. It's a condition. They're very, very bright people. Albert Einstein could not spell to save his life, okay? He was confused every morning as what to wear. So he bought 7 of the same suit, all dark brown, one for each day of the week. He didn't want to think about what to put on, okay? genius, but they are a little quirky sometimes. If this spells we, we're good. You don't want to spell you. Okay? If you have trouble with this, and some people do. All right, anyway. Northwest. Which direction is that? That way. But when it says northwest, that's exactly halfway between north and west. That makes a 45-degree angle. Okay? And if that's 45, well, so is this. So, start here. And again, you got to read the whole thing before you do your picture, right? Because if you put B in the wrong spot, like here, this is north of Erie. Well, where do I put Erie? Whoops, screwed that up, okay? Bellevue is 30 kilometers north of Ayr. Okay, that's the first piece of information. Stop there. Churchville is 18 kilometers northwest of Ayr. Actually, to be realistic, if that's 30, yeah, that looks like just over halfway. Okay. Where do I want to draw this 45 degrees? Right there. Okay? Because this one, that doesn't really help me. I want it inside my triangle. Calculate the distance between Bellevue, there, and Churchville, there. That's what I want to know. That's opposite angle A, so let's call it little a. Okay? Does that make sense? Now I got a picture. Don't need to look at the words anymore. Can I solve for little a here? Do I know the angle opposite it? Yeah. A squared is, now I'm not going to write it out, let's just make substitutions. 18 squared and 30 squared minus 2 times 18 times 30 cosine 45. Cosine law. By the way, if you're like a visual person, you use cosine law when you have what they call side, not that one, side, angle, side. Think this, okay? I got this side, and I have the angle in between the two sides, okay? I don't care if the triangle is like this, the triangle is like this, side, angle, side, okay? Side, angle, side. You can use cosine law. All right, so A, put that in your calculator to the nearest kilometer. Do I have units? Yep. Okay, the hard part with that one is getting the picture, because they're all confused with our soggy wieners. All right, so again, here's the equation. Tomorrow we'll do, this is the same cosine law, but it's in terms of the angle, okay? So today, just number 1 to 5. Some of you guys got rewrites happening in about 20 minutes.